Recently at 21st Subroto Mukherjee Seminar, Indian Air Force Chief Air Marshal A.P. Singh expressed concerns over increased militarization of China and Pakistan, saying that forces were growing at a rapid pace at India's northern and the western borders. The Indian Air Force Chief has also expressed concerns over delay in India's indigenous fighter program, especially the Tejas Mark-1A Alpha project, which is currently hindered by slow supply of F-404 jet engines from the United States. India has been trying to indigenously develop its own jet engine, Kaveri, but it is yet to meet required standards. So let's try and understand what are the challenges in building an indigenous fighter jet engine.
We have our concerns from the northern as well as the western adversary. They are all, both of them are increasing their air forces at a very rapid pace. As far as China is concerned, it is not just the numbers. Even the technology is going at a very rapid pace. We just saw that recent flight of the new generation fighter which they have pulled out, the stealth fighter.
The development of a fighter aircraft jet engine is a monumental endeavor that requires advanced engineering, significant financial investment, and a robust industrial base. Fighter jet engines are among the most complex machines ever created, serving as the heart of the aircraft by providing the thrust necessary for supersonic speeds, agility, and combat performance. The journey begins with defining performance requirements based on intended role of the aircraft. Engineers conduct extensive research on aerodynamics, thermodynamics, and material science to conceptualize a design that maximizes efficiency, thrust, and durability. Conceptual simulations and wind tunnel testing are used to validate initial designs. Jet engines operate under extreme conditions with components exposed to temperatures exceeding 1500 degrees centigrade and immense mechanical stresses. Advanced materials such as titanium alloys, single crystal superalloys, and ceramics are developed and selected to withstand these harsh conditions while maintaining structural integrity and reducing weight. Each component, such as the compressor, turbine, combustor, and nozzle, is meticulously designed and tested. The high-pressure compressor must achieve maximum air compression with minimal energy loss, while the turbine must efficiently extract energy from the hot gases to power the compressor. After individual components are developed, they are integrated into a prototype engine. This stage involves aligning subsystems for optimal performance and ensuring compatibility with the aircraft. Advanced manufacturing techniques such as 3D printing and precision machining plays a vital role in achieving the required tolerances. The prototype undergoes rigorous ground and flight testing to validate performance, reliability, and safety. Engineers assess the engine's behavior under various operational scenarios including extreme temperatures, altitudes, and stress conditions. Data collected during testing is used to refine the design before obtaining certification for operational use. India's Gas Turbine Research Establishment, the GTRE, which is part of Defense Research and Development Organization, the DRDO, has announced that Kaveri engine has been cleared for in-flight testing, marking a significant development in India's indigenous aero-engine development program, according to the latest reports. The non-afterburning Kaveri engine, developed to power India's first stealth unmanned combat aerial vehicle, Ghatak, has been cleared for in-flight testing. GTRE announced this on December 23rd of 2024. The engine is now ready for real-world performance evaluations aboard a specialized flying testing bed. In this phase of testing, dry Kaveri engine will be mounted on an FTB to evaluate its response to various flight conditions, its integration with aircraft systems, and its overall reliability in a dynamic and a challenging environment. The engine's endurance and efficiency in extended flight will also be tested. FTB for in-flight testing of dry Kaveri engine is a modified IL-76 fixed-wing 4-engine turbofan aircraft. During the trials, Kaveri dry engine will replace one of the IL-76-4 engines. The testing location would be Gromov Flight Research Institute located near Moscow, Russia, where modified IL-76 is based. GTRE hopes to complete all tests by 2025 and commence limited series production by the end of 2025, early 2026. The GTRE hopes to complete all Kaveri tests by the end of 2025 and commence limited series production by the turn of 2026. The GTRE aims to develop a 90 kN engine to replace the American 404 engines on Tejas Mark-1A fighter jets within the next decade. The Gas Turbine Research Establishment, the GTRE, is actively pursuing a significant leap in India's defense capabilities. Once the dry Kaveri plus the afterburner section is successfully tested on the flying test bed, the GTRE is likely to propose a government funding request for the development of 90 kN engine. This new engine, an enhanced variant of current Kaveri engine aimed at replacing the F-404 engines on Tejas Mark-1A fighter jets within the next decade. The primary objective behind this development is to create a new generation of Kaveri engines capable of generating 20 to 25% more thrust than the existing dry Kaveri engine. This increase in power will be achieved by refining the core of Kaveri engine, which is currently under development. Once the enhanced core is validated, it will be coupled with the new afterburner section, enable the engine to generate 90 kN of thrust, making it a capable replacement for F-404 engines currently powering the Tejas Mark-A fleet. Unlike the F-404 engines, which suffers from 7 to 8% power degradation in hot conditions, the Kaveri engine is designed to be flat-rated. This means it will maintain its thrust capabilities even in the extreme heat and high-altitude environments typical of India's operational conditions. The proposed Kaveri 90 kN engine is expected to make a substantial difference to the Tejas Mark-1A program. It will replace the current F-404 engines in the mid-life of these fighter jets, helping to keep them operational for next several decades. As the Indian Air Force plans to induct over 220 Tejas Mark-1 and Mark-1A jets over next 7 to 8 years.